Hello everyone. Today let's solve the problem heavy intervals. Previously we solved the problems on try, right? So now we'll be solving the problems on intervals as well as the greedy, right? So today we'll be solving the heavy intervals problem. So basically this was asked done finally round 3, division 1 plus division 2, right? So we'll be solving heavy intervals problem today. So you can just go through the problem. It's very easy to understand. I'll just summarize the problem so that it will be very easier for us to solve the problem, right? So what does the question state here? Just give me a second, 1 second. Yeah, we are given n intervals. We are given n intervals. This is intervals based problem, right? So we have been given n intervals in the form of this one. This is nothing but left, this is nothing but right, right? So we have been given n intervals. So this is I. Yeah, we have been given n intervals li comma ri with a weight ci, with a weight ci, with a weight c basically, right? So with a weight c, right? So we are allowed to independently rearrange the lists L, R, and C. We are able to independently arrange the list L, R, and C. Just keep this in mind. Our goal is to form valid intervals such that left is always less than right. Left is always less than right. So this is very important, right? So what we need to do, what is our main goal? We have to form valid intervals such that li is less than ri, right? Or l less than r basically. Left less than right for all and I, for all I. And we have to minimize the total weight as well. We have to minimize, C is nothing but the weight here, right? So we have to minimize the total weight, right? So we have to minimize the total weight, or we have to minimize C here, right? So we have to minimize the total weight, which is calculated as, to calculate the total weight, we'll be going with this formula, C I into Ri right minus left, right minus left, C into, this is C into basically, right? C into R minus L basically for each interval. So to calculate the total weight, we'll be going with this formula, C into R minus L for each interval. So or all the endpoints are unique. So that's what they have stated in the question. All the endpoints are unique here. So we are given n intervals. We are given n intervals L, R with the weight C per unit length. We are allowed to independently rearrange the list L, R, and C. L, R, and C. Right. So our goal is to form valid intervals such that L less than R for all I, and minimize the total weight, which is calculated as C into R minus L for each interval. We have to minimize the total weight, which is calculated as C into R minus L for each interval. All the endpoints are unique. All the endpoints are unique here. All the endpoints are unique. So let me delete this one. This is fine. Let me delete this one, man. This is fine. I hope this part is completely clear. So let me come to the input output part here. This is it for the question basically, right? So our main goal is to form the valid intervals such that L is less than R for all the intervals I, right? This one we have to keep in mind. Our goal is to form valid intervals such that left less than right. And also we have to minimize the total weight, which is calculated as C into R minus L for each interval. These two things we have to keep in mind, man, right? So we have been given two inputs here, right? So they have clearly mentioned in the input part. So this two state set, we have been given two inputs. So this is one input and this is one input, right? So for this one, we have to get the output 2400, 2400. And for this part, we have to get the output 42. For this part, we have to get the output 42. So that's what they have mentioned here, right? We have been given two inputs. One is 283, 12, 23, 100, 100 basically, right? So these are the intervals. So here in this case we have to get the output 2400, and for the second input we have to get the output 42. For the second input we have to get the output 42, right? So I hope this part is completely clear, man. I hope this part is completely clear, right? So just give me a second here. Did I do anything? So yeah, this is fine. This is the input output part basically. So let's consider this example for the approach. I insist you to try out with the second one so that you understand the question better. So I'll just consider this part of the input, this part of the input for the approach. So how we got the output 2400, and what will be the approach that we'll be going with, and what will be the data structure that we'll be using with, how we can implement. Those are the things that we'll be discussing in the approach part, right? So I'll consider this input. Whatever we discuss for this input, try to implement the same or try to articulate the same thing for the second input. I insist you to do that because your intuition may be different from me. Can write the you may write the better code. You may write the better code. In terms of code, you may write the better code than mine. Your code might be better than mine, or your intuition might be better than mine, right? So maybe uh, it is easier to understand. Maybe your intuition is easier to understand. Maybe your way of solving the things might be better, right? Better. So I insist you to try out the same things for the second one, or you can just by listening to the approach, you can just try to solve it in a different way as well. I insist you to do that. Don't follow blindly. That's what I wanted to tell you, right? So this is fine. This is fine. So now let's discuss the approach. As we are done with the question and this one input output part, let's discuss the approach followed by the edge cases, and then followed by the complexities, and then let's write the code. First, as usual, let's discuss the approach first. See here, I have considered the first input. As I have said, I have considered the first input 2 2 8 3 18, this one 12 23 100 this part. I have considered only the first input, and the output that we need to get here for the first input is 2400 or 2400, right? I hope this part is completely clear, man. Let's move on with the further things. Let's go with a step-by-step explanation here. First thing is we can rearrange L, R, and C independently. Means this one left part, this is right part, as we are dealing with the intervals problem, right? So this is nothing but the weight, nothing but C. We can rearrange left, right, and this one weight independently, right? Then we can combine and sort all the endpoints with a tag. Then we can combine and sort the all the endpoints with a tag. So we'll be going with 0 for left, we'll be going with 1 for right. 0 for left, 1 for right, right? So this helps pair the smallest, nothing but the left with the smallest possible r. So smallest L with the smallest r. So basically when we combine and sort all the endpoints with a tag, nothing but 0 for left and 1 for right, this helps us pair the smallest left with the smallest possible r, right? So while keeping li less than n, the condition in the question, we have already discussed this one several times in the question itself. Li has to be less than ri. They have given this one in the question itself, right? They have given in the question itself. I read this one loudly. So we discussed the question already, right? So this criteria or this condition we have to meet, right? So that is the reason we'll be combining and sorting all the endpoints with a tag. Basically you have already guessed that we'll be making use of the sorting, right? I didn't tell here this one, I think. So we will be going with a greedy with the stack plus sorting approach. Basically in simple terms, we'll be going with greedy and sorting. So for the intervals problem, uh, greedy is the best approach. Actually, most of the problems we will be solving by greedy. Most of the problems will be solving by greedy approach, right? So and also sorting. Most of the problems we will be solving by greedy and sorting. Just remember this one for the what do you call intervals problems. Usually we'll be solving intervals problems with the greedy and sorting, with the greedy and sorting. Just remember this part, right? So for the trees, usually we'll be going with the BFS or the DFS along with the recursion. Usually in the linked list, usually we'll be making use of the dummy nodes to simplify the edge cases and then to solve the problems easily, right? In the same way, when it comes to approach for the greedy, for the this one intervals problems, usually we'll be going with the greedy as well as the sorting. Greedy along with the sorting, right? So just remember this one, right? Let's move on with the further things. So after sorting, so here see 3, 8, 12, 23 we have. So we'll be sorting this one in the ascending order, right? So 3 first comes the 3, then comes the 8, then comes 12, then comes 23, right? Then comes 23. So this is the this one intervals we have, right? So here we are going with 3, 8, 12, 23. Left, left, this is right, right, right. These are the intervals. Basically we have sorted them in the ascending order: 3, 8, 12, 23. Left, left, right, right. So this is fine. Now we have to match each right with the most recent unmatched left. For that we'll be making use of the stack. For that we'll be making use of the stack. So this is the reason we'll be making use of the stack. So you can solve the problem without making use of the stack as well. But so when we make use of the stack, it will be very easier for us to understand, uh, and the approach will understand the approach basically. uh, the approach will be clean in simple terms, right? So that is the reason I have made use of the stack here. So we will match each right r with the most recent unmatched left, right? So for that purpose we'll be making use of the stack. So now intervals formed as this one, because right, left and right, right, most recent unmatched left we are saying. So 12 with 3, 23 with 8, right? 23 with 8. So this will be 3, 12, 8 and 23. This is left, left, right, right. We are matching right with the left as per the this statement. Match right r with the most recent unmatched left, right? So this one, 23r, this will be matched with the left, second left, right? So I hope this part is clear. 3 comma 12 and 8 comma 23. Length consists of 9 and 15. 9 and 15 means 12 minus 3, this is the length. 23 minus 8 here, you can just calculate, right? So this will be 9, which is considered here length 9, and 23 minus 18, 8, sorry, will give us 15. So this is considered as 15 here. This is fine. I hope this part is completely fine, man. Next, let's move on with the sorting the lengths. We have 9 comma 15. So we know how we got 9 and 15. This is nothing but the length. This is nothing but the length. So the third part in the this one input, this is nothing but the weight. So this is nothing but the intervals that they have given: 8, 3, 12 and 23. This part 100 and 100, this is nothing but the weight. We know this one, right? This is nothing but the weight. We will be sorting the weights descending in the descending order. So we have the same value. We don't have to worry for this particular test case. We have to sort weights in the descending order, but for this particular problem, we have the same value. So we can just write 100 comma 100 here, right? So the formula, if you remember, was C into R minus L. Nothing but Ci into Ri minus this one, Li, if you remember, to calculate, right? Um, this one. So here multiply the smallest lengths with the largest weight. So here in this case it is 9 into 100. 9 into 100 length. Length we have 9. 9 into 100 plus again we have the length 15. So where did 9 and 15 come from? So this one, we have the intervals formed was 3 and 3 comma 12 and 8 and 8 comma 23, right? So here we'll do 12 minus 3 and 23 minus 8 to get the length. So we got 9 and 15 over here, and we have successfully sorted the length. Now we went with the descending order. We have to sort the weights descending, in the descending order. Basically we have the same value, so we don't have to worry that much. Here in this case it is 9 into 100 plus this one, 15 into 100. So 9 into 100 will give us quite obviously 900, plus here in this case 15 into 100 will be 1500 or 1500. So 1500 plus 900 is nothing but 2400. So the output that we got here is 2400. And what is the approach that we used for this? Basically we went with a greedy with stack. Also we made use of the stack, right? So we have already discussed this one. Plus we sorted, we went with the sorting as well. We have successfully sorted the this one in the second step. I think the intervals part, sorted endpoints, this one here, we went with the sorting as well, right? So the output that we got here is 2400, which which is equivalent to the output that they have given for the example 1 in the question, which is equivalent to the output that they have given in the question 1. So 2400 equals 2400, right? So which is equivalent to the output that they have given for the example 1. So our approach works absolutely correct for this case, right? So our approach works absolutely correct for this case. What shall we do now? As we are completely familiar with the approach, now let's do one thing. Let's move on with the complexities part. Just give me a second here. Yeah, we have to discuss about the complexities part, right? So just give me a second here. So what would be the time complexity here? The time complexity would be big of n log n, because here see, uh, we are going with the greedy approach. Basically it will be big of n. right? Big of n along with the stack. So greedy and stack will be big of n. And we are making use of the sorting as well. We have to sort the endpoints that we have already seen in the approach, right? Sorting will lead us to the big of n log n. Big of n log n. We have solved n number of sorting problems already, right? So here sorting will lead us to the big of n log n, and sorting is the dominant factor here, right? So we are sorting the endpoints, weights, and lengths, if you know, right? So accordingly with the approach, we are sorting endpoints, weights, and lengths, and sorting is the dominant factor, which will lead us to the time complexity of big of logarithm n log n, basically, right? So what would be the space complexity here? Space complexity would be big of n as well. So the time complexity would be big of n log n, and the space complexity would be big of n for the code that we'll be writing in the future. So how the space complexity would be big of n? Because we have to store the endpoints, weights, and interval lengths, right? So we have to store the endpoints, weights, and interval lengths. That will lead to the space complexity big of n. So again, the time complexity and the space complexity for the code that we'll be writing in the future would be big of n log n and the big of n. I hope the complexities part and approach part is completely clear. As we are completely familiar with the complexities and the approach part, we are good to write the code. Let's start writing the code. Now let's start writing the code, man. Right, so here I'll just come to the compiler. So first we'll be making use of the different utilities. So I'll just go with the import java.util.star. So this is fine. So let's go with the class. I'll just name the class main. So you can just give anything, or you can just give the question name itself heavy intervals. I'll just go with the class main here. So within this one, let me go with main function or the main method. So this is fine. So let me delete this one. Yeah, this is fine. So we don't have to use the input output exception for this. This is fine. So first we will be going with the input reader and number of the test cases also we have to consider. So this is nothing but the input output part, man. So I'll just write this one quickly. I'll just be making use of scanner sc equals new scanner. This is fine of system dot in. This is fine. And also I'll just go with int t equals c dot. So this one will be next int. So this is fine. So next part is we have to go with the I mean we have to read the number of intervals. Also we have to go with the arrays for left and right endpoints, right? For the left and right endpoints we have to consider the array, and also we have to consider the array for the weights as well as long for the sorting with the collection. So we will be considering array for weights, we'll be considering arrays for left and right endpoints. Also we have to read number of intervals. That let's do that first, right? So this is mainly related to the input output part. So let me write this one first, the test cases. Then let me assign n to sc nothing but scanner dot next int. So this is nothing but the number of intervals. Now let's go with the yeah, let's consider arrays for left and right endpoints. Means I'll just go with long l equals new. This one will be long of n, and r equals this one new long of n within the array. This is fine. Now we have to go with the array for weights as well. So this one will be just consider long. So why here this is, yeah, this is fine. L, right? So this is C I'll be considering for the weights. This one will be new long of n. So this is fine. Yeah. I hope this is fine. L and R we have considered left and right. So nothing but the left and right endpoints. And this is for the array for the weights, line number 10. So we are done with this part, right? So just give me a second here. Yeah, this is fine. Now we have to read all the left and right endpoints along with the weight. Left endpoint, right endpoint, and the weight. We need to read all, right? So for that one, let's go with the iteration part. Nothing but for loop. Simple here. Int I equals 0. I less than n. Let's increment the I here. So this one will be L of I equals sc dot next int, next long actually. So this one will be next long. This is fine. We are reading all L of I. So let me copy the same thing here. Let me copy the same thing here. This is fine and this is fine. So this one will be in this remains same, less than an I plus plus. So this one we have to change here. So I forgot to give, this one is nothing but L of I. So this is left endpoint, right? So we have to assign this one to the left endpoint. Same thing. This is right endpoint here, R of I. This is fine. The final one is for the weight. So this one will be C of I for the weights. So this is fine. We are done with this part. So we are successfully reading all this one, what do we call left endpoint, right endpoint along with the weights. So next part is we have to combine left and right with the tags. We have to combine left and rights with the tags. Tags in the sense 0 for the left and 1 for the R. We have discussed the same thing in the approach. Same thing we are articulating in the form of code here. Same exact thing we are articulating in the form of code, right? So just give me a second here. Just give me a second, man, here. So how can we write that here? Long, this one is fine. And this one is new long of, so this will be 2 into n. This is fine. So this is 2, this is fine. Next part is, let's move on with the iteration part. This one will be int I equals 0, I less than n, I plus plus. So this is fine. For loop, let's tag the left points with 0 and also let's tag the right points with 1. So I can just give in this way, points of I 0. So this one will be left of I, uh, and also points of I 1. This one, let's assign this one to 0. This is fine. This one will be points of n plus I, 0 is equal to R of I. This is fine. This is equal to points of n plus I 1, and let me assign this one to the 1. So line number 19, we are just tagging the right points with 1. So here we are tagging the left points with 1 and here we are tagging the right points with 1. That's what we are doing. So we are just combining L and R with a tag 0 for L and 1 for R basically. Accordingly with the approach we are going, right? So we are done with this part. Let me come out of this one entirely. Next, what we have to do, we have to sort all the points by value. We have to sort all the points by value. If equal, then left has to be kept before the right. We will be sorting all the points by value, and if the values are equal, then we have to keep the left before right accordingly with the approach that we have discussed. So I'll just go with the arrays dot sort here. This one will be points comma a comma b. This is fine. So this is fine. This one will be a of 0, a of 0 not equal to b of 0, not equal to b of 0. So we'll be making use of the ternary operator here. So if it is true, then I'll just go with long dot compare. So I'll just go with a of 0, a of 0, comma b of 0, comma b of 0. So if this is false, if the condition is false, means if a of 0 uh, is equal to b of 0, then what we have to do, I'll just go with long dot. So I would have copied the same thing and made the necessary change. This is fine. Long dot compare, let me type instead. So this one will be a of 1. So just give me a second here. This I have written correct itself, right? So this one will be a of 1 comma b of 1. Instead of a of 0, we just have to change this one to a of 1 comma b of 1. This is fine. I hope this part is completely clear, man, right? We are just sorting all the points by value. If it is equal, then we have to put the right before, I mean left before right, sorry. Then we have to sort the weights in descending order as well. So in our case, in the first example, we had the same value 100 and 100, so we don't have to we didn't worry that much, but still we have to sort, we have to consider all the test cases, right? So for this test case, we have to sort all the points by I mean we have to sort weights, sorry, in descending order. So I can just write in this way, arrays dot sort here, arrays dot sort, we have to sort in descending order, right? So this will be collections, this will be collections dot reverse order dot reverse order, yeah, dot reverse order. This is fine. So we have successfully sorted the weights in descending order. This is fine. The next part is we have to go with the stack to watch left endpoints. We will be going with the stack to match the left endpoints, right? So I can just write in this way, stack long. So let me go with the variable name stack. So this will be new stack. So this is fine, new stack. So after this, we have to store the lengths of the formed intervals, right? So we have to store, for that one, let's make use of the array list here. So I'll just go with list, so which is of the type long, and I'll consider the variable name length, and let me assign this one to new array list, new array list. So this is fine. So this part is completely clear. Let's move on with the iteration part. So we are left with the iteration part, right? So I'll just go with for long, let me, we have to consider the individual point here, out of points pts we have considered, right? So I'll just go with p of pts here within the for loop. So if left point, then we have to push into stack. If right point, then we have to pop left, then we have to pop left, and we have to get the length, right? So if it is left point, then we have to push it into the stack. If it is right point, then we have to pop left and get the length. That's what we'll be doing here, right? So we are going yeah, we are just articulating whatever we discussed in the approach, just in the form of code. We are just uh, yeah, we are just articulating the same thing that we discussed in the approach in the form of code. That's it, right? So let me write the simple if condition here. P of 1 here uh, equals 0, then stack dot push. Oh, this is fine. Stack dot push P of 0. This is fine. The next step would be else. If it is right point, then we have to pop left and get the length, right? So this one will be length dot, I'll just make use of the add property here. This will be p of 0. I can write in this way, p of 0 hyphen stack this one dot pop. So yeah, this is fine. We are done with this part, right? So we are left with certain things. Now we have to sort the length in the ascending order. We have to sort the lengths in the ascending order. Third point in the this one approach, we have to sort the lengths in the ascending order. I'll just go here. I'll just go with collections dot sort of length. Let me pass the length here. So this is fine. So for this part, we have to go with the final answer, nothing but long answer equals, let me assign this one to the 0. Let me assign this one to the 0. So I'll just go with a for loop here for int I equals 0, I less than n. Let me go with I plus plus. Let me increment I here. This is fine. What we have to do here, answer equals 0. This is for the final answer. So this is fine. We are just initializing with this 0. So here what we have to do, we went with the iteration. We have to multiply the shortest lengths, right? So we have to multiply the shortest lengths with the weight. Basically 9 into 100 plus 15 into 100 we did, right? So last step, calculation part, right? So that we have to write in the form of code basically. So how to write that? We have considered the answer variable. Answer equals answer plus this one will be len dot, we have to get the value, iterated value, nothing but I can just write get uh, get of I into we have to go with the weights, right? Accordingly with the this one descending order. We sorted the weights in the descending order. We can just go with C into I mean C of I, right? So this is it, right? We are just articulating the same thing in the form of code, whatever we discussed in the approach basically. So the final part here would be we have to output the result. We have to output the result either. So we have not made use of the buffered reader, right? Buffered reader or the print writer basically. So we cannot just make use of the out.println this time. We have to go with the system out println, right? And we don't have to flush the output as well, right? So for this part we'll be going with a system out println. So I'll just go with a println here. Println what we have to output the result, nothing but the answer. Ans is the variable we have considered. So this is it, we have successfully output the result. So this is it for the code. We have successfully written the code. Now before checking the code with different inputs, I just want to copy paste the signature starter template. Just give me a second here. So yeah, I'll just paste it over here. This is fine. So let's concentrate on the logical part. So I'll just come here. Let's consider different inputs. So this one, let me copy this one. We have to get the output 2442, right? So we have considered the first input for the approach within the approach. So we know I insist you to try out the same thing with the second, this one, second input by considering the second input, right? So I'll just get to know the problem better. And again, I'm telling your intuition may be better than mine, your way of writing the code may be better than mine. Maybe the code might be smaller, maybe the thinking might be better. So I insist you to try out with the second input that they have given in the question, right? So here I have copied this one input entirely. We have two inputs. The output that we need to get here is 2442. Let's check the same. So we have, yeah, I have misspelled here. Just let me remove line number 23, right? So yeah, now what? In thread main java.util.empty stack exception. So where stack where I have used, just give me a second here. Let's check what is wrong, man. So we have initialize this one. This is fine, and there's a new link. Long. This is also fine. We are going with a capital long for the weights actually. This is fine. Line number 30. So this is fine. Yeah, we are. Oh, this one I copy pasted. I think I forgot to delete this one. Just give me a second. So this has to be left, right, and weights. Left and point, right and point, and the weights, right? So I don't know. I didn't change there itself. Instead, I gave L of I, R of I, C of I equals this one. So that is the reason we are getting the error here. So let me run this one again. I hope it works now. Yeah, we are getting the output 2442. So this was basically a wrong thing. So I copy pasted the same thing, I think. So this is fine. Yeah. Now, as it works correct for all the inputs that they have given in the question. So let me paste the entire code here. We have to select C. Had already selected, I think. So this is fine. Let me hit the submit button. I hope this works for all the test cases, man. Let's see. Let's see. So you can clearly see here running on test cases. So here we have the code got accepted, just right, just almost. So here the time limit is 1 second basically. So we have 983 milliseconds here. So this is fine. As I have said, we don't have to make use of the stack here, or we can just go with a better approach as well, better than this one. It just got accepted, man. You can clearly see here 983 milliseconds. You can just optimize this one. You can just optimize this one in your own way, right? So uh, I hope the solution part is completely clear. I hope the solution part is completely clear. We just went with the greedy along with the sorting, and also for uh, Also we have went with the sorting to sort the intervals, to sort the left and right intervals basically, right? So we went with the sorting here, so this is fine, I think. So this is fine, I hope, right? So I hope this part is completely clear. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.